Hello. Let's go over some homework so people don't complain, and let's do it quick so we can finish watching the UConn game. Alright, so 15 through 31, and 15, as you so eagerly were to complain about, refers back to items 14 and 13. So we take a trip back, and we don't really have to work too hard because we know this already. If each diagonal of a parallelogram divides that parallelogram into, we see that this diagonal makes two triangles. Two congruent triangles. Alright, 14, given this triangle above, opposite sides of the parallelogram are congruent, and the opposite angles are also congruent. And then it says, explain why the theorems in 14, that's these two, are corollaries, which means they're theorems based on other theorems. So how is this related to this? And it's just because opposite sides, two sides being congruent, and this angle between them being congruent, shows that our two triangles are congruent. So how is it corollaries? Because by using CPCTC. That's why we know number 13 works, because number 14 is true. And that's it. That's not so bad, was it? Really? Alright, given our lucky parallelogram here, we can say triangle KCL is congruent to, well, K corresponds with U. C would actually be L up here, and then L would be backwards as well. And that's a triangle. Alright, solve for X. If KCU, so this angle here is 10x minus 15, and angle K is 6x plus 3. Alright, so if this is a parallelogram, we know that consecutive angles will always be supplementary. So we just say that 6x plus 3 plus 10x minus 15 has to add up to 180 degrees. This angle and that angle are supplementary. We combine our terms here, 6x and 10x, that's 16x. 3 minus 15 is negative 12 equals 180. We just solve for x. Plus 12, plus 12. This is pretty good. 16x equals 192. How many times is... Well, 16 times 10 is 160. Plus 32, that's 2 more, so x has to equal 12. Probably. Alright, so that gives us b. b is 12. Let me do c, so we can erase all this because it's a separate issue here. This one's pretty good. I like this question. I lied to Javi. I told him there was no systems of equations, but this is totally a system of equations, so sorry, buddy. So KL is 2x plus y, and I don't care about LU. I want this opposite side. UC is 14. And since it's a parallelogram, we know opposite sides are congruent, so we can say 2x plus y equals 14. Alright, then we could say LU is 7, and KC down here is 5y minus 4x. And these two are equal, are congruent. We can say 5y minus 4x equals 7. Then we just got to figure out how we want to solve this. Let's go with substitution, because we got a y sort of hanging out by itself here. So if I move this 2x to the other side, I get y. Oops, y. So y equals 14 minus 2x. So now anytime I have a y, which this totally is a y, I can replace it with 14 minus 2x. And I just happen to have a y right here. So I'm going to put 14 minus 2x there. I'm going to write the rest of this equation around it. So 5 times that minus 4x equals 7. And we just do some distributing. 5 times 14 is 70. 5 times negative 2x, negative 10x minus 4x equals 7. And then this isn't so bad, relatively speaking. So we combine our like terms. Negative 10, negative 4 is negative 14. X equals 7. Bring the 7 to the other side. Minus 70, minus 70. So negative 14x equals negative 77. Okay, I don't know what that equals. So 77, it's going to be a decimal of some sort. Let's say 4. 4? Did I do something wrong here? 50, 70, negative 14. Hold on. No, this is wrong. Ugh. 7 minus 70 is negative 77? Well, who taught me math? I'm sorry, hold on. Hit the rewind button. This all goes away. 7 minus 70 is negative 63. Okay. This hopefully make more sense now. So I still don't know what this is. So 63 divided by 14. There's my 4. That's 3. Oh my goodness, what's wrong with me? 3. 4 times 14 is 56. This is 7. Alright, this works out the way I want it to. And then 14 goes into 70 5 times. This is x equals 4.5. Okay, and if we know x, we can solve for y. Let's put it right here. So 4.5 is x. We can go back to red here. Y equals 14. 14, clearly that's a 14, minus 2 times 4.5, 14 minus 9, so y just equals 5. Alright, that was a good question, I like that one. Okay, that was fun. Alright, number 7. Proofs! One whole proof you had to do, oh my goodness. Theorem, diagonals of parallelogram bisect each other. Write that in if then. So if it's a parallelogram, then the diagonals bisect. Alright, draw a figure for the theorem. Okay, so let's give ourselves a parallelogram here. There we go. And then it says label it along with the diagonals. So let's draw a couple diagonals here. It doesn't say what letters to use. So let's say A, B, C, D. And the middle we can call E. Didn't see that coming, did you? Alright, so we want to show that our diagonals bisect each other, which means we have to show that this side is equal to this side and this side is equal or congruent to this side. Can we do that? Of course we can. So these are two sides of a triangle. So what if we can prove that this triangle is congruent to this triangle? Perfect triangle. Okay, can we do that? Yes, we can. So we start with the given. It's given that this is a what are we doing? Oh, it's a parallelogram. So A, B, C, D. I'm paying attention here. Okay, given. Alright, now let's see. How can we begin to prove stuff? So, we know these are congruent. Right, so we can say that AB is congruent to CD. And that's just opposite sides of a parallelogram are congruent. So that gives us a side. How about these angles here? What can we do with that? Well, we know these are parallel to each other, so we can say that AB is parallel to CD, and that's the definition of parallelogram. Okay, and if we have parallel lines, we have a transversal running between them. We can talk about, I actually have two transversals here. Let me do both these at the same time. We'll knock this out quick. We can say that this angle is the same as this angle, and this green angle is the same as this green angle. So we can say angle BA, let's call it E, is congruent to this one on the other side, DCE, comma, and then we can say green angle AB is congruent to this triangle CDE, which doesn't sound as fun as Abe. And both of those are just what do we want? Interior angles theorem. Okay, so that gives us an angle and a side and an angle. So now we can say that triangle, not A, but triangle AB is congruent to triangle CDE. That's by angle, side, angle. Okay. Now, since they're congruent, we can talk about our diagonals here, which is our whole goal, which is to say that this side is congruent to that. So we can say AE is congruent to CE, comma, and then our other diagonal, we'll do this at the same time. We can say B, the word B, not the letter, is congruent to ED. I know it's not alphabetical order, but it's more fun to say ED. And that's just corresponding parts of congruent triangles are congruent. And then our last statement, which we didn't write here, so give it the reverse arrow treatment. We can say that AC and D bisects. Whoops, that's not a B, that's a D. It's sort of backwards. Bisects. We can even put each other. And that's just definition of segment bisector. And that's what we're looking to prove, so we probably could have written that right here. Perfect arrow. Alright, that was really the longest problem on here, so we skip ahead a little bit. Rhombus is a parallelogram with four congruent sides, so graph it, USMC, Semper Fi rhombus over here, 1, 1, 4, 5, 9, 5, and 6, 1. Yeah, we can even connect these. Perfect. Right? Yeah. Alright, verify it by finding the slope of each side. Okay. Well, the slope of, oh, we're supposed to label these as C. Wait, backwards. S, M, C. Okay. So we can say, we can start with the easy ones here. We can say SM and UC both have a slope of, well, 0. Right? 0 over anything is 0. And then the slope of us and MC, we can say this goes over 3 up 4, right? So 3/4, and that's the same for both of them. Wait, why am I saying 3/4? Rise over run. 4/3. I know what I'm talking about. Just a little sleepy. Okay, so us is the same as C, and it's both 4/3. Okay, so since the slopes are the same, and these lines are parallel, it is indeed a parallelogram. And then we can confirm it's rhombus by finding the length of each side. Well, again, we can do these short sides pretty easily. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and then this just happens to be a 3, 4, 5 triangle, so we know all the sides are 5. And you can put US equals MC and so on. Okay. The last thing it wants is the slopes of the diagonal. Okie dokie, we can do that. So let's draw in our diagonals. Okay. Fix this. There. So the slope of the diagonals we're going to look for from U to M. So it goes from 1 up to 5. So that's 4 over what's our run from 1 to 9 is 8, so that's 1/2. Okay, and then SC, this goes down 4, -4, and then over 2, so that simplifies to -2. So here are our two slopes. And then it says, complete the theorem, the diagonals of the rhombus are. What does that have to do with this? So we look at our two slopes, look at how they're related, and be like, oh look, they're reverse reciprocals of each other. And if you have two lines where the slopes are reverse reciprocals, we know that those two lines have to be perpendicular. Smiley face for perpendicular lines. Okay, that wasn't so bad. We're almost done. Okay, Utah. How exciting. It's a rhombus. Okay. So use properties to find whatever. This is just like the parallelogram one, except now it's a rhombus, so it's actually going to be easier. So UPT, that's this one here, and we know this is a right angle. We just showed that. Okay. So we could just say 4x plus 18 equals 90. So minus 18 minus 18. We get 4x equals 72. And if my math is right, then x should be 18, right? 18, 36, 72. Yeah, okay, good. There, done. Alright, solve for x and y if, all this. Okay. The advantage here, though, is it's a rhombus. So all the sides are exactly the same. So we're not going to have to work too hard, I don't think, especially because it gives us one of the sides is 24, which means all of these have to equal 24. Right? So I'm going to stay away from this one because it's got two variables in it, but I can solve these two. 5 times what number plus 4 equals 24? Well, so this has to equal 20, so x is just 4. That's like child's play stuff right there. And y, 2 times the number minus 8 is 24, so 2 times what minus 8 is 24, so plus 8 is 32, half of 32 is 16. Right? Check my answers here, make sure I'm not going crazy. Yeah, okay, piece of cake. And then last one, solve for x of PAH. No, I want a different color. PAH. And this is 8x plus 2. And PAT. Okay, and this is, yeah, 10x minus 10. So we go with that. Take a quick snack break. Okay. So it's a rhombus. So we said that the diagonals are angle bisectors here. So this and this are the same. So we just set them equal to each other. 10x minus 10. Minus 8x from both sides. Add 10 to both sides. Not rushing this, but half times over, and I don't care about this anymore. I mean, I do care. I heart this stuff, right? That's what I tell people. 12 is 2x, so x is 6. And we just wanted x. I don't actually care what these angles are, but it'd be 50. Right? Okay, who cares, right? And that's it. And that answers 1, 2, 3, 4, 5 of the questions. That's not so bad. You guys will make it through the rest, right? You guys are amazing. Lee.